1.2, finding limits graphically and numerically. All right, so we're going to start out with this famous function, sine x over x. And so if I were to figure out what f of 0 is, all we do is substitute in, right? Miss Kraft, what's sine of 0? 0. All right, and then we'd have it over 0. And what does 0 over 0 imply?
Undefined.
It's undefined, or it creates a what? A hole. It creates a hole. It's that indeterminate form that creates a hole. However, we could possibly still do a limit on that. All right, and so our f of 0 is undefined. It creates the hole. However, if we do a limit as x approaches 0 of sine x over x, I have the graph here for you. What is a limit? When you do what? When you do what? When you approach from both sides, and we get what? Arbitrarily close to a what? A y value. And so as I trace this from both the left and the right as I go to 0, what does it look like it's going to? It looks like it's going to 1. Did it ever reach 1? No, it never reached 1. However, the limit as x approaches 0 of sine x over x is equal to 1. So this next one, let's write it out. We have a limit as x approaches 0 of x divided by the quantity square root x plus 1 minus 1. And what we're going to do is we're going to put this thing into our fancy calculator. We're going to graph it. So if I were to try to direct substitute 0 in, if I try to substitute 0 into that numerator, what do we get on the numerator? 0. And what do I get in the denominator when I substitute in 0? I also get 0, which created a what? A hole. But does that mean a limit won't exist? No, we have to go further. And so when I approach this thing from the left and the right, sometimes we have to do things with numerically, aka with a table. All right? And so what we're going to do is we're going to calculate these with a table. Now, I already have this little thing filled out, but we're going to do it with our calculator. So if we look at this table, what does it look like this value is approaching?
2.
It looks like it should be approaching 2. However, did it actually give me a true value of 2? No. However, the limit looks like it's going to approach 2 from both the left and the right. All right? All right, so on this next one, we have my function, and this function's a piecewise, so let's write it out. So my function is 1 when x does not equal 2, and my function is 0 when x does equal 2. And so what we're going to find is we're going to find a limit as x approaches 2 of this piecewise function. That's what we're going to solve for. And so what we're going to do is we're going to do this one graphically. All right, I think that's the easiest way to kind of think about this problem. Let's pick something to the left of 2. Let's pick something to the left of 2. Like 1. That sounds great. So if we find 1, what is f of 1? F of 1. Anything but 2 is going to be what? 1. So f of 1 is 1. How about f of 0? 1. How about f of 2, or how about f of 1.5? 1. Everything is going to be 1 except for at what? 2. At x equals 2, there's a little hole right here, and then everything else is 1 again, is it not? Yeah. However, at 2, where is my dot? Where am I filled in at x equals 2?
0.
It's at 0. All right? And so graphically speaking, that's what the graph would look like. It will be at 1 everywhere except for at x equals 2. However, let's find a limit, though. What's a limit again when you do what? When you approach from both sides. So when I approach this from both sides, where is it going? Where should it be? It should be at 1. So my limit as x approaches 2 of this function is 1. However, if I asked for a value, what is the value at 2?
0.
The value is 2. Remember, the limit is where it should be, and a value is where it's at. All right? Next one. So this next one, we have the limit as x approaches 0 of absolute value x over x. This is a very famous one, and I'll show you I had a question yesterday in my BC class of a similar question to this one, and I'll actually say that one too after we do this problem. All right. Again, we try to substitute in 0. What do we get?
0.
We got 0 over 0. We got a whole, didn't we? All right. Now, on those other two examples that we just did with a whole, did my limit exist?
Yes.
It did. But does that mean it exists at all holes? No. And so that's what we need to figure out. So let's pick something right of 0. Let's go right first. So let's pick something right of 0. 1. I like that, Trace. So if we substitute in 1, what do we get? We get 1. I agree. 1 over 1 is 1. Pick something else to the right of 0.
2.
Okay, we're going further away to 0. Okay, so let's substitute in 2.
1.
1. All right. Let's get closer this time, Emil. Closer to 0. So like in between 0 and 1.
0.5.
Love that. So let's substitute in 0.5. What do we get?
1.
We get 1. So everything to the right, what do we think we're going to get? 1. Except for a 0, Mary, what do we get? We get a whole. So at 0, it's a whole, but everything to the right, we're going to say is 1. Does everybody agree with that?
Yes.
All right, cool. And so now let's do it from the left. So let's pick something from the left. Negative 1, obviously. And so if we substitute a negative 1, what do we get? We get negative 1, don't we? And so at negative 1 is negative 1. All right? And negative 2, it's also what? Negative 1. Let's get in between. Let's get closer to 0. So what do we get when we get closer to 0? Like, what would you say? Negative 0.2. Read my mind. All right? So when I substitute a negative 0.2, what do we get there? We get negative 1. So everything to the left of 0 happens to be what? Negative 1. Except for a 0, it's a what? It's a whole. Now, what is my limit? What's a limit, though, when I do what? When I approach from both sides. So as I approach from both sides, as I approach from the right, it goes to 1. When I approach from the left, it goes to what? Negative 1. Well, what happened? It's a jump discontinuity. All right? And so my limit, though, does not exist. I had a special high five. All right? My limit doesn't exist because my reason is a jump discontinuity. Continuity. There it is, continuity. All right. So there's different versions of this special high five one. Like, for instance, the one that came up yesterday was something like limit as x approaches 2 or something of like absolute value x minus 2 over x minus 2. All right. That's essentially the same problem. Okay. It's still like this kind of famous problem of absolute value x over x. All right. So that's kind of the same problem there. Let's look at this next one. So I have a limit as x approaches 0 of 1 over x squared. The limit as x approaches 0 of 1 over x squared. So if I substitute in 0, what happens? I get undefined. I get a number over what? 0. What happens at a number over 0? A vertical asymptote. So first of all, you guys are smart people. Am I going to have a limit at a vertical asymptote? No, dog. It's not going to exist. Now, do we know the exact reason why this doesn't exist, though? No. But what happens at vertical asymptotes? They either do what? They go to positive infinity or what? Negative infinity. That's the exploration that we have to do. All right? I'm not going to do this one with a table. I used to do this with a table. We're going to think about it graphically now. All right? So let's go a little bit to the right of 0. So what's like a little bit to the right of 0?
Maybe like 0.01.
I love that. All right? So if we substitute in 0.01, all right, is that going to be this is a positive number over a really small what now? Positive. So what's a positive number over a really small positive?
Positive.
Big positive. So it goes to what?
Infinity.
Positive infinity. All right? Now, let's go something to the left of 0. Like what? Negative 0.001, right? And so what happens to that negative 0.001, though? What did I do to it? I squared it. So now I have a positive number over a really small what? Positive. So what does it do again? It goes to positive infinity. And so my answer to this limit is still what? Does not exist. Because this one increases without bound.
Wait, so we can't put that limit.
So this one, we're going to find a limit as x approaches, we'll say 0 again, of, I don't know, -2 over x. Why not? All right. So limit as x approaches 0 of -2 over x. We just made it up. So what do? We substitute in, right? What happened again? We get undefined, which created a what? A vertical asymptote. So my limit is definitely not going to exist. Is everybody following me?
Yes.
All right. So my limit does not exist. Now we need to figure out why. And so this is where I like to think of it graphically. So pick something a little bit right of 0.
1.
A little bit.
0.
Like 0.001, like a really small positive. Are you following me? And so now I have a negative number over a really small positive. So what did it do as it approached from the right?
Went down.
It went down. Where did it go down to?
Negative infinity.
Cool. Is that a direction or a concept? Both. All right. Is it a number?
No, it's not a
No,
number.
it's not a
We
number.
know that for
All
sure.
right. So now let's go from the left. And so if I go from the left, so I have like a really small negative. So now I have a negative over a really small negative, which creates a what?
Really big positive?
A really big positive. All right. And so now the reason behind why this thing doesn't exist is what?
It's different directions.
It increases and what? And decreases without bound.
Are we ever gonna have one of these that like is an answer? What's an example of something that is an answer?
All right, the next one. I have a limit as x approaches 0 of sine of 1 over x. All right. So I have a limit as x approaches 0 of sine of 1 over x.
One question. What does oscillate mean?
Let's talk about it. Let's talk about it. All right. So if I try to substitute in 0, I get sine of what? 1 over 0. So I have sine of a vertical asymptote. First of all, that's kind of like, whoa, that's something that happened that's wrong. All right, that braked. That broke. You following me? All right. And so what we need to do is we need to get kind of fancy, and we need to get closer and closer to 0. So can everybody agree that if your denominator grows and your numerator stays the same, that it's getting smaller?
Yeah.
Does everybody agree with that? So like 1/10 is actually less than 1/2. All right, good at that? All right, and so if I did this fancy manipulation, and because if I divide by it, it's really multiplying by its reciprocal, and so forth, what is sine bounded by?
-1 to 1.
-1 to 1. And so what's happening here is that as I get closer and closer to 0, it actually gets really fast between -1 to 1. All right, it goes taka, taka, taka. All right, it oscillates between -1 and 1.
That's what oscillates.
All right. So oscillating behavior. So this limit does not exist. That's my answer. And the reason behind why it doesn't exist is because it oscillates. And I have taught for a long time. I have seen many spellings of the word oscillate over the years. All right. Try your best. If you get it correct, that'd be great. All right. But I've had lots of different spellings. All right. Now, I think all textbooks have like 3 reasons a limit doesn't exist. I think there's 4. And so let's talk about it. All right. So 1. What's one reason a limit will not exist?
Approach is different.
Approaches 2 different numbers from the left to the right, a.k.a. what? Jump discontinuity. All right. Another one. What's the next one? It increases or decreases without bound. And then the third one? It oscillates. Now, if I were to ever write a textbook, there's a 4th one. When does a 4th one have a limit that doesn't exist? Miss Walker? At an endpoint. All right.
Miss Cordova, buddy.
All right. So, at an endpoint. Why can we not do it at an endpoint? Why?
Because you can't
We can't come from both sides. It can only be a one-sided limit. All right. So there's your homework, except for I'm going to reduce it a little bit. I'm going to say no number 8 and 12 and 14. All right. So no number 8, 12, and 14. So basically 2 through 6 and 10. And then 15 through 20.